Hi, um, good afternoon, everyone. In today's lecture, we are going to go ahead and talk about differential equation. We've already talked about difference equation, and we saw that in difference equation, the time variable that we have is a discrete variable. What I'm going to do today is called differential equation. And in differential equation, when we say differential, beta, time is a continuous variable. So differential equation is one where time is a continuous variable. Am I clear on that part? Okay. So now in we're talking about the first order differential equation. When I talk about first order differential equation, it means that I am just going one step back. One step back, money. If I tell you that my, savings in 2023 are a function of savings of 2022, if I'm just going one step back, then we are saying that it is first order differential equation. But if we go many steps back, like for example, if I tell you that savings in 2023 are a function of savings in 2022 and savings of 2021, then it is a second order differential equation. So whether it is going to be first order or second order, it depends on how back I'm going to go ahead and how back I'm going to do these things. Am I clear on that, beta? Okay. Now, try to understand that here we have said that time is going to be a continuous variable, and we have to understand that the unknown variable is a function and not a number. But abhi tak, in difference equation, we were talking about GDP. When we talked about GDP was assumed to be discrete. एक number था. And we were saying GDP in 2023 can be a function of GDP in 2022. So when we were talking in terms of numbers, when we were saying that, then beta, of course, it was a continuous variable. It was a discrete variable. And when we talked about discrete variable, of course, it was difference equation. But now we are not talking about discrete variable. Now we are talking about the fact that this is a continuous variable. तभी मैंने savings बोला. Savings रोज change हो रही हैं, continuity में change हो रही हैं, minute में भी change हो सकती है, right? So then we are talking about differential equation. The function is a function of time. Achha, अब let's see the mathematical representation of this. Huh? So in order to show you the mathematical representation, but this represents dx by dt. So dx by dt is telling you how the variable x changes as time changes. जैसे जैसे टाइम चेंज होगा, as my dt मतलब change in time. So as my time will change, how my variable x will change. Changes in variable x as t changes, this is called as dx by dt. And we are saying that it is a function of the variable x and the time component. It's a function of variable x and time component, where x itself is a function of time. So क्योंकि x तो टाइम पे डिपेंड करता है ना, मेरी सेविंग्स कितनी है वो इस पे डिपेंड करेंगी कि क्या आप 2023 में पूछ रहे हो या 22 में, आज पूछ रहे हो या कल पूछ रहे हो. शायद कल मेरी वेल्थ चेंज हो जाए बिकॉज मैंने स्टॉक मार्केट में इन्वेस्ट किया हुआ है और वो फ्लक्चुएट कर रही है. So my wealth can fluctuate. My savings will accordingly fluctuate. So when these variables fluctuate as time passes by, it means that they are a function of time. So I can say that if x represents my wealth, then x will be a function of time. My wealth will be a function of time. It will be dependent on time. Okay, beta. So now then I can rewrite this differential equation. How have I written it? I am saying that the change in variable x as time changes is a function of the variable x, which itself is a function of time and a function of time. Now, let me just talk about partial differential concept once. बेटा एक बारी थोड़ा सा समझो. If I tell you that z is a function of x and y, and I want to tell you that do a total differentiation. Do a total differentiation. How will you do that? You will tell me dz is equal to how function changes as x changes dx, how function changes as y changes dy. This is what you will do. So you will go ahead and in order to do the total differentiation, you will do something like this. हाँ बेटा, यही चीज यहाँ पे है. Z is a function of x and y. So if I have to do dz, you will have to go ahead and you will have to tell me how the function changes as x changes dx, how the function changes as y changes dy. This will be the total differentiation of z. ये चीज I am going to use a lot in a lot of places, so you should be well aware of it. अब हम थोड़ा सा कॉन्सेप्ट ऑफ डिफरेंशियल के एग्जांपल्स पे चलते हैं. सो दिस इज द फर्स्ट एग्जांपल. तो देखो जरा ध्यान से देखना है बेटा. हाँ, दिस इज सेइंग हाउ x changes as time changes is a linear equation. It's a linear equation. This is simply xt plus t. So if you will go to Sydsaeter and Hammond, this is 21.1, जो आपका पहला part है, the first part of Sydsaeter and Hammond. We are covering that beta. Huh? Similarly, how capital changes as time changes. Change in capital as time changes, that can be written as a linear function of capital and time. तो ध्यान से देखो, there is one component of the variable and other component of time period specifically. Similarly, here also better, there is one component of the variable. My variable is capital now. And there is other component which represents the time. Other component of the time period. Clear? Okay. Aim will be to find xt or kt which differentiated with respect to t gives the RHS. ये थोड़ा सा हमें समझ. हाँ. Okay. Now, suppose I give you some differential equation. Suppose I tell you how x changes as time changes. This is x square t plus 1. ऐसा कुछ मैंने आपको दे दिया. That how x changes as time changes. This is this equation. From this, beta, what is my aim? What do I want to find out? My aim is to write x as a function of t. This is what I want to go ahead and do. Currently, I have dx by dt as a function of x's and t's. But what I want to achieve is x as a function of t. This is what my solution will be. I want to find out the value of x from here. That is what my aim is. Right? So this is what we are saying. My aim is to find the value of x. Just in case, I will teach you just in a while. In this case, what we can go ahead and do now, we can just bring all x terms on one side and we can just bring all t terms on the other side. And then we can integrate. So differentiation and integration, जब हम करेंगे, I will get something in terms of x here, something in terms of t here. So x will be a function of t. So your aim, kya aim hai? What do we want to achieve? I will show you how to do these questions. But my aim is that if I give you a differential equation, if I tell you how x changes as t changes, if I give you this equation, then my aim, what I want to achieve in such questions is to write x as a function of t. I want to find out what x is. X ka kya value hai as a function of t. That is what I want to go ahead and achieve, right? So Another thing that you have to remember is sometimes dx by dt is also represented by x dot. X with a dot above, this represents dx by dt. हाँ बेटा, ठीक है बेटा. Now, so if I am writing a differential equation like this, ध्यान से देखो, हाँ, then this just means that यहाँ पे I have written x dot. So x dot just means that I have dx by dt. So dx by dt is t square minus 1. So beta, if dx by dt is t square minus 1, I can take dt on the other side and I will get t square minus 1 dt. I can also go ahead and do integration on both sides. This is 1 into dx. Differentiation of integration of 1 will be x. Integration of t square will be t cube by 3. Integration of 1 will be t. This is plus c. So I have been able to get x as a function of t. हाँ बेटा, I had dx by dt is equal to t square minus 1. So I had dx by dt as a function of t. But from dx by dt as a function of t, I have been able to find x as a function of t. So this will be the solution of my differential equation. This will be the solution of my differential equation. A particular differential equation can have more solutions due to the presence of C. So beta, ye according to what condition you are given. Suppose it tells you that when t is 0, x is 1 in this equation. So can I put t as 0? Yes, I can. So 0 to the power 3 minus 0 plus c, and x will be 1. So beta, it will be c is equal to 1. So a particular differential equation that I've got in this case will be x is equal to t cube by 3 minus t plus 1, because I have got the value of c as 1 based on the initial conditions given to me. That in time period 0, the value of x is 1. Similarly, if they change the initial conditions, if they tell me that in time period 0, the value of x is 2, then I will be plugging in 2 here. So I will be getting the value of c as 2. So then my differential equation will change. My differential equation will be x is equal to t cube by 3 minus t plus 2. So on the basis of your initial conditions, you will be able to find the value of c. Right, beta? You will be able to find the value of c. So as this c will change based on the initial conditions, this same differential equation will keep taking different forms because of the presence of the c, which will take different values. Okay. Now, let us go ahead and let us take one more question. Something like this can be asked in exam. So what is this saying? This is saying consider the differential equation x dot is equal to x plus t. Prove that x is equal to minus t minus 1 and x is equal to e to the power t minus 1 are the two solutions to the differential equation. You have to prove that these are the two solutions to the differential equation. So let us try to do this better. So what can we go ahead and do in this case? Now, let us begin with the first one. So it says x dot is equal to x plus t beta. That means it is telling me that dx by dt is equal to x plus t. Dx by dt is equal to x plus t. I need to prove that when I will solve this differential equation, and from here when I will find the value of x as a function of t, these two equations I will get. I can get x is equal to minus t minus 1 and I can get x is equal to e to the power t minus 1. हाँ बेटा. अच्छा एक बात बताओ. If I am getting x is equal to minus t minus 1, beta, what will be dx by dt? Dx by dt will be minus 1. If I ask you from here, what will be dx by dt? Dx by dt will be e to the power t, if I just differentiate, minus 1. Dx by dt will be e to the power t minus 1. Yahi hoga. This is what will happen. Now, just have a look here. So, from here, we are given that x dot is equal to t plus 1. We are given that x dot is equal to t plus 1. If this x is equal to minus t minus 1 is a solution to this problem, अगर ये इसका solution है, तो अगर हम यहाँ पर x की जगह पे minus t minus 1 put करें, तो हमें same answer मिलना चाहिए जो हमें यहाँ मिल रहा है, अगर ये इसका solution है. So if instead of x, I am going to go ahead and put minus t minus 1, that is what I'm going to do here, I should be getting the same solution. So dx by dt is equal to minus 1. So when I, instead of x, when I plug this value of x, I am getting answer as minus 1. And this equation also means that dx by dt should be minus 1. So both are giving me the same solution. Both are giving me the same answer. That means this x satisfies this equation. Similarly, beta, in the same equation, if instead of x, I will plug this value, then I should get dx by dt exactly equal to this. Let me try that. So I am given from here, dx by dt is equal to x plus t, and instead of x, I need to plug in this value. So I can just go ahead and say e to the power t minus 1 plus t. So I will get the answer as e to the power t minus 1. This is exactly this value that I was getting by solving dx by dt. So I am getting the same answer here also. That means it is a solution to this problem. So we have proved that both of them are in fact solution to this problem.